At this point, let's invite Kevin Spina, graduate student in chemistry, to discuss Foogly.
Are the slides working? Well, this is Foogly. It's not working. It's in the loop, I think. There we go. Will it work? Let me check. Okay, it works. Okay, great. All right, good afternoon, everyone. Welcome. My name is Kevin Spina. I'm a graduate student at the Department of Chemistry, and crazy enough to have started a startup while in grad school called Foogly. It was started based on the realization of a nasty duality in our country in the beginning of the pandemic, where we have such excess of food that an upwards of 50% ends up in the landfill, which yearly costs to about $1 trillion, about 1% of our GDP. Moreover, at the source, at the farmers, about 1/3 of the total agricultural production is wasted on the farm, which is about 0.5% of the GDP. Now, we have another issue that we have to worry about down the line, is the imminent issue with climate change, with an expected reduction of about 70% of arable land. So Foogly first started out with a concept of how to tackle this food waste crisis, and we identified quickly that there's no incentive for small farmers to save food, there's no storage for them. So we developed almost developed a deep tech singular solution which allows for all stakeholders to transact in a streamlined value chain. So we've tested and confirmed our model by looking at working with small organic farmers buying either ugly food, soon to spoil food, either process them to make them into products or directly sell them to consumers. But now I'll be talking about the other direction that we have been entering and our patent pending technology, where we're working directly with food waste and making bioplastics and biopolymers out of them in one singular step in water. And we hope, and through the identification of 4 key markets through customer interviews, that we can break the space of making virgin plastics, fishing lures, garden supplies, and hopefully synthetic wood. So here's the technology. Basically, you like ragu, food waste, everything's in it. You have all the material for epoxy plastics, so cellular fatty acids. You have to sonicate it down to the cellular level. And what I found out was it all acts as one. You can hijack the enzymes inside food waste that behave just like our liver to not only create epoxy plastics in situ, but also polymerize this and make it inside water. And this is not obvious. We had to do rigorous calculations and simulations, and I've identified out of 100 reactions that there are 4 key components. With some fancy calculus, you're able to determine on a batch-by-batch basis how much peroxide and at what rate do you put it in to create a biopolymer or bioplastic. And this was actually the first run of this method, where I used about 250 grams of cells and was able to make a biopolymer that was lasted for about 2 years, and after 2 months, excuse me, and after an interview with Home Depot, we made garden pots, and that's on my display table. And if we are to target this market in plastics, we see globally it's expected to rise to about a $1 trillion market by 2030. In the US market, we have about a $223 billion market for plastics to cater to 330 million Americans. And we see that our technology to fit right into the niche area as a quick win, worth roughly either the fishing lure market and the bioplastic sphere, which was roughly about $40 billion, and our top competitors have a small portion of the pie. So from start to now, I was able to have an idea, have partnerships. They cashed a check. I'm not sure if I have the patent yet, the trademark yet for my name. We filed a patent form, and hopefully we will have our platform ready to go by the end of January. And to start, with the help of this competition, I'll be able to address right away the scaling problem. Our B2C model will fund our B2B model. We have saved about 3 tons of pumpkins this year. If we need a requisite insurance policy to go to a food lab space, we already have generated our second MVP, which you're capable to touch and play with upstairs to see how it looks. And we are in a method of en route to generating both virgin bioplastic beads and other MVPs that were identified through customer interviews, and also we have to test the viability, and we have a 1-month market, so hopefully we can make fake wood by then. So that is the gist of what I've been working on for the past 2 years. Thank you.
Check out the full playlist from the 2022 Innovation Forum or visit kellercenter.princeton.edu/innovation forum to learn more. Subscribe for more videos on entrepreneurship, design and design thinking, societal impact, and innovation coming out of Princeton University.